Hey there, Algebra 1. We are in Unit 1, Lesson 2. We're talking about data representations today, what you see right here, data representations. How do we represent data? Let's look at this first, notice and wonder. So if we look here, it says battery life. The dot plot, this right here is a dot plot. The histogram, and the box plot, so how they label it, box plot. Sometimes it's called a box and whisker plot. So the dot plot, histogram, and box plot summarize the hours of battery life for 26 cell phones constantly streaming video. What do you notice? What do you wonder? All right, this lesson, actually pieces of this lesson are considered a review for things you may have learned in earlier math courses. I can't make any assumptions because we have new students every year that you did learn this before. So we are using this as a bit of a review. So I will be going at a tad bit faster pace, not much, you may not even notice. But I expect you to pause and write things down. Like if you didn't know that was called a dot plot, you might want to label it. A histogram, label it. A box plot or a box and whisker, like whisker plot, you might want to label it. For our notice and wonder, the goal here is to get the idea that data can be represented in different ways. And representing data in different ways has different meaning behind it. Sometimes it's more visually pleasing in a certain way. Sometimes the data has more relevance in a certain way, things like that. Learning how to create different data displays. All right, so looking at these things, what do you notice? What do you wonder? All right, we can notice that the box plot seems to have a vertical line of symmetry. Okay, so that's something that we notice. Here I notice that 5.5 hours is the most common battery life. Each one of those dots represents one cell phone's data. Okay, so 1, 2, 3, 4, 5, 6 cell phones had a battery life of 5.5 hours. That's pretty short. Some cell phone had a 2.5 hour battery life, which would fall, right in here. And also, that would be the lowest value right here. I may wonder, is 3 hours of battery life included in the second bar? Like, is this number included in the second bar or the first bar? I wonder. Like, where is 3 hours included? I don't know. Why does the histogram have intervals of 1? So that's 1 hour. Why do we have intervals of 1 instead of 2? I don't know. Okay. And how do you create a box plot from the data? Something we're going to go over today. Like this one right here, this box plot, how do you create that? Like these are called whiskers. Okay, where do the whiskers come from? How is that created? All right, so let's move on to figure out how we do this. All right, we're going to create some things. 1 second. All right, so I made a note here, and we'll talk about that note in just a second. So let's read our instructions. A histogram can be used to represent the distribution of numerical data. The data represent the number of days it takes for different tomato plants to produce tomatoes. Use the information to complete the frequency table. All right, so frequency means how many times it occurs. So we are going to put all of this data into this frequency table. Now what I've written here is the lower boundary is included, so 40 to 50. 40 is included. The upper boundary is not. So 50, sorry. The upper boundary is not included. So the lower boundary is included, the upper boundary is not. All right, so as we find our frequency, we know where to put it. So let's find everything between 40 and 50. 1, just 1. All right, so now we're going to do 50 to 60. 1, 2, 3, 4. Skip it. 4. See how that 60, we're not going to include it in this interval because the 60, that's the upper boundary, it's not included. So we're going to include that here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. And 1. All right. Now, let's use the set of axes and the information in your table to create a histogram. All right. So we see we already have our intervals there. So they are going to help us. Our 40 to 50, we had 1. So I'm going to start right at 40, go up to the 1, and over to 50. That's our first bar. Next one is 50 to 60. There were 4. Not very straight line, sorry. Then we had 9. 60 to 70. And then we had 9 again from 70 to 80. See how my vertical lines occur at the right interval on the horizontal axis. Then we had 6. And then just 1. I don't know if you hear my boys in the background. They're playing a video game, and they are a tad bit loud. But they can get worse. So I'm not going to say anything right now because it's actually okay. All right, so there we go. Okay, but what about this one? The histogram that we just created has intervals of width 10, like 40 to 50, 60. Use a set of axes and data to create another histogram with an interval width of 5. How does this histogram differ? All right, well, we need different intervals. So we're going to have to do 40 to 45, and then 45 to 50, 50 to 55. You remember the lower bound includes, the upper bound does not. 55 to 60, 65 to 70, 75. Nope. Sorry. Got a little ahead of myself, didn't I? I bet you guys are like, whoa, 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 Miss Carly, stop, stop, stop. You missed some. I did it again. Sorry, I'll pay closer attention. 70, 75, 75, 80, 80, 85, 85, 90, 90, 95, 95. Pen's getting a little backed up again. 100. All right, so let's count them. This time we're going to use circles. So 40 to 45, 0. 45 to 50, 1. 50 to 55, 1, 2, doesn't include. 55 to 60, 1, 2. 60 to 65, 1, 2, 3, 4. 65 to 70, 1, 2, 3, 4, 5. 70 to 75, 1, 2, 3. 75 to 80, 1, 2, 3, 4, 5, 6. 1, 2, 3. I think that says 85. 1, 2, 3, and 1. There weren't any there. Okay. All right, so we're going to have to graph those. Oh, why aren't they moving? Oh, that's not good. Hold on a second. Oh, there they go. All right, hold on. All right, this is going to be a little bit of us going back and forth and back and forth and back and forth. All right, 40 to 45 was 0. And then 45 to 51. 50 to 55. Oh, sorry. 2, 2, 4. See if we can remember that. 2, 2, and 4. Uh, 5, 3, 6. 5, 3, 6. A few more. 3, 3, 1. 3, 3, and 1. All right. How does this histogram differ from the other one? I think I can see them. See if I can shrink this down a little bit. That's cool. So how is it different from the other one? Like, what do you see here? Let me think for a minute. Well, it shows more detail, right? There are more bars along the horizontal, okay, with shorter heights. The heights are actually shorter. Shows a little more detail, okay? I'm going to write a vocabulary word. So there's more detail. With the distribution shape. And that actually means this shape, like the distribution shape. That was awful. My pen. Okay. So a little more detail with the distribution shape. It's still going. I got the pen right here. It's still writing down there. I'm afraid if I erase it, it's going to erase the whole thing. Oh, nope, it didn't. It just erased a bit. All right. So yeah, that's the difference. So you might want to write down the distribution shape of something new, and it's just that curve that the shape makes that you can sort of make with a highlighter or shade it with a pencil. That's the difference. All right, let's zoom this back in. All right, so a box plot can be used to represent the distribution of numerical data. So using the same data as the previous activity for tomato plants, find the median and add it to the table. What does the median represent for these data? All right. So the median means you're going to add everything together and divide by the numbers of numbers. I need to get my calculator. Oh, I think I have one right here. Yep. Okay, so you're going to take this and it says the median. Okay, add up all the numbers and divide by the numbers you have. Let's see. There are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There are 30 numbers there. So I'm going to push pause for a second and add all of. Actually, no. What we're going to do is learn something in here. All right. So everybody, pick up your calculators if you have them. I hope to have passed them out today, and you're going to hit. You're going to hit this button right here. It's the stat button. So hit that button, and then you're going to want to hit enter when it says calc. All right. Now arrow up. I just arrowed up. I hit the clear button. Let me find the clear button. So arrow up, hit the clear button, and then arrow down, and you're going to empty that list. Okay, I'm arrowing over, arrow up, hit the clear button, and then arrow down and empty it. Now in this list one right here, you're going to enter all of that data. All right, I'm going to push pause though. Just enter all those numbers in one at a time. So like 47, 52, and you'll see I've written right there, all in list one. I'm going to push pause and do that though, because you don't want to hear me do that. You'll be bored out of your mind. I think I'm going to have to erase all this stuff too, because I can't see it. All right, enter all those numbers into list one. Okay, if you see, I've entered the last number in, and it says that there are 30 numbers in my list one, which is good because that's how many times there, how many numbers there should be. That's how I know I've typed them all in. All right. All right. So now I want you to, second, quit. All right. And then go back and hit the stat button. Stat. And now you want to arrow over and highlight calc. And then arrow down, to one variable stat and push enter. Okay, that should say list one in there. Mine does not, so I have to change it. I'm going to hit second, and down here is list one. So it just changed it to list one. Okay, so now I'm going to do one variable statistics on list one, and there we go. All right, that's all the information we need to draw a box and whisker plot. We're here, they're going to go through the steps to do it. We just used our calculator. It's fantastic. I just arrowed down, okay? This is what was printed out. I arrowed down until I saw min, Q1, median, Q3, and max. Because if you look on your paper, that's what we have. Our min is 47, which you should have on your calculator. Sorry, draw, pencil. 47. Our Q1 is 62. Oh my goodness. It's so painful. Let's try again. 47, 62. Our median is 71. Q3 is 78. And the maximum is 90. What do all these things mean? All right. The median is the average of all the data. Okay? Okay, I just double checked something, and I don't want you to write this down wrong. It's the middle value. Okay? So it's the middle value of the data. Okay, so if we ordered all the data from lowest to highest, it's the middle one. Now, find the median of the smallest. I don't like how they say least, of the smallest 15 values to split the data into the first and second quarters. So we would look at all the data and list the smallest 15 and then find the middle of that and split it into the first quarter of the data and the second quarter of the data. This value is called the first quartile, and we call it Q1, quartile 1. So the value 62 splits it into the first 25% of the data and the second 25% of the data. And then we have the median. So that means this is actually 50% of the data, because 25 plus 25 is 50. All right, then find the value, the third quartile that splits the data into the third and fourth quarters and add it under Q3. So this right here splits the higher 15 numbers into 25% and 25%. So this right here is actually 50%. Okay? Add the minimum and maximum values to the data. So 47 is actually the smallest value in your data, and 90 is the biggest. This right here is called the 5-number summary. And I showed you how to do that with your calculator, and we could actually do it listing the numbers and finding the middle number, then taking the lower half and finding the middle of the lower half, and taking the upper half and finding the middle of the upper half. Okay, that gives us our 5-number summary: the median, the min, the max, and Q1 and Q3. Okay, use the 5-number summary to create a box plot that represents the number of days it takes these plants to produce tomatoes. So we want our median Q1 at 62, Q3 at 78. That's our box. That box represents the middle 50%. Okay, and then we do the minimum at 47. This whisker represents the smallest 25% of the data. And then we do the maximum at 90. Okay, so that's 25% of your data, that's 25% of your data. All right, I think my headphones just died, so give me a second.